Good morning, everybody. My name is Sean Parker. I'm the technical evangelist for Geomagic Solutions. I'd like to thank you all real quick for taking the time out of your morning or afternoon today to learn about Geomagic design. Today I'm going to go through a pretty comprehensive demonstration of the capabilities of design. But before I get started, I just want to go through a couple of quick slides outlining exactly what you're going to be looking at today. So this is Geomagic design. It is from Geomagic, which is 3D Systems software arm. Basically what you're looking at is a powerful mechanical design software. It's a history-based solid body, sheet metal, and assembly modeling software package. There's a number of time-saving features built in, like standard parts library, so you don't spend resources modeling off-the-shelf parts, and dimension wizards within the 2D documentation that places dimensions on your engineering drawings automatically for you. Now, just as an aside here, we'll be doing chat. So if you use your GoToWebinar and you have any questions for any of the panelists, you can outline it or you can ask it within the GoToWebinar screen, and I'll get to that in a minute here. But otherwise, you're kind of muted here. So get back on track. Geomagic design does complete assembly design. It can handle very large, complex assemblies. Like today, we'll be looking at some stuff from a 3D Systems ProJet 3D printer. And it also does sheet metal design. It's very, very intuitive how this works. It's a very intuitive interface. And you'll be shocked at how affordable we've actually made all of this power. So before I move on, I'd like to bring it to your attention that we are actually talking about two separate design packages here. We have Geomagic Design and we have Geomagic Design Elements. So with Design Elements, you can create, document, and render solid models, as well as access the standard part libraries that we've brought into this. Now with the full package, you get all of this, of course, plus the ability to create freeform surfaces, sheet metal objects, and use direct modeling, direct editing on imported parts. We can do motion simulation, as well as open up native files from other CAD packages. So you just heard me say earlier that we're going to be, or we're able to work with large and complex assemblies. So this is the assembly that we'll be working with today. This is, like I said, 3D Systems ProJet 3500 printer. And we're going to be looking at a motor pulley assembly from the assembly that moves the build table around. So that's it down there. And that'll be our finished product here. So before we get into modeling, I'd just like to take a quick second to pose a poll question to the audience, just to kind of get an idea of who's in here. So go ahead and vote on that. We'll take about 20 or 30 seconds and then jump right back into it here. Okay, looks like we're done there. Thank you very much for voting on that. So let's go ahead and get started. Today we'll be modeling, like I said, a pulley that controls the motion of the build platform, and we'll bring that into an assembly and use top-down design to create a sheet metal bracket in it. And then finally we'll document that in 2 dimensions, perform motion analysis on it and FEA on the assembly, watch it run, and then we'll bring it into KeyShot and apply some photorealistic rendering to it. So when I launched Geomagic Design, I have kind of my splash screen here, but it actually allows me to choose the option of what I'm going to be working on. I can start with a solid body. I can start with a sheet metal part, an assembly, a bill of materials, or a 2D documentation. Or actually what I'm going to do is open up a part that I've already started, which is the pulley. So what I've got here is just the beginnings of my pulley. You can see I've got the grooves in there. That was a solid body revolve. So I'm going to finish this part by adding the hub, and punching a couple of holes for the hub itself and the some weight savings, and then add some fillets and some chamfers for assembly and strength constraints. So I'll start off here by selecting the face that I want to operate on, or I can just use the XYZ planes here and activate 2D sketch. I'll start on the center hole, so I'm going to just use my sketch tool to create a circle, place that on the center of my my coordinate system here. You can see as I drag it along, it's got a dimension applied to it. So if I have a dimension that I have in mind, which is 1 inch, it dynamically updates as I place that and puts my sketch entity where I want it with that dimension. Now, kind of one of the cool things about Geomagic Design is from within the sketch window, I can actually click anywhere on the screen, and it brings up a menu of different actions I can take with that current sketch that I'm operating on. So if I jump over to part features here, you can see that I can do an extrude, a revolve, a sweep, a loft, or a helical boss, or all of the same things, and actually use that to cut out an object. So I'm going to extrude a boss here, and that jumps me directly into the extrude tool. So I didn't have to leave my 2D sketch and find out the tool that I was going to use on the menu bar. So it saves me a little bit of time, and it's pretty intuitive. So I'm just going to select the type of extrusion that I want to do and the dimension associated with it, which is going to be, and that updates, and you can see my preview updates in the model view window as well. So go ahead and accept that, and it creates my extrusion and joins that with the original body. I'm going to do a similar tool, but I'm going to do that just on a face, so I don't actually have to create sketches on reference geometry. I can do them directly on the face. Go back into 2D sketch mode here, and I'm going to punch a couple of holes in this thing for weight savings. Now you can see, if you can see, there's a constraint where it's applying the center of this hole directly over vertical above that center axis that I've got by applying a red constraint to it. So I'm just going to make this a 0.75 inch hole and accept it. And when I come back out here and select this again, I can go directly into my extrude cut tool. I'm just going to go through all. It's going to extrude cut through everything that I've got there and accept it. Now I want to pattern that hole, circular pattern, by selecting that face, selecting the center, either reference geometry, axis, or just a face of the solid body that I've created here, and I just want to create 3 equally spaced holes there. So that's one way to cut a hole, but we actually do have a hole tool built in. So if I select that, my hole tool comes up. I've got options for just a basic hole. I can do a counter bore, a counter sink, or a counter drilled, a counter sink hole, or a tapered hole. So I'm going to use a counter bored hole, and I can change all of the dimensions that everything comes in here. So I'm going to make this, oops, a 1/4 inch deep, 1/2 inch wide, and that dimension. That's asking me what surface I want to place that hole on and where I actually want to put it, and it's going to be right there. And once again, it's giving me a preview of what that hole is going to look like. When I accept it, it builds for me, and we're ready to go here. So just add a couple of finishing touches to it. I'm going to place a couple of 1/8 inch fillets on some of these surfaces. And apply. And close. I'm going to add a chamfer to this edge right here. So that's pretty much it for this. I'm going to go ahead and save my model here. And then when I go over to my Viewing and Analysis tab, I can go back to my home window, and I can enter the assembly mode, where it prompts me to bring up the file that I want to start this assembly with. So I'm just going to place that somewhere here in the center. You can see it's ported right over exactly how I modeled it. I want to bring in another object to start assembling with. So add a part assembly. I'm going to bring in my hub. And this is a step file. This is just a generic file format. Any other CAD package can create this. And since it's just it's an unknown, well, it's not an unknown format, but since it's another format that's not a direct format from Geomagic Design, it gives me some options to kind of heal this and make it a little bit better, higher quality, just if there's any weird options with some faces or anything like that as I import that. So it'll heal that and bring it in as a body. So I want to start adding some assembly constraints here. I've got two options, quick and standard. Quick is very, very intuitive. Just allows me to select two items. And so if I select a cylindrical face, it's going to extract the reference vector from that. And I just want to align it with pretty much anything in here. I'll select this face. And when I do that, you can see that it snaps its position relative to it. And I'll go ahead and accept that. Of course, I can still rotate each object about its axis, and I can still move them up and down relative to one another. So I'll go ahead and select that face, mates to that face, and I'll accept that again, and exit my quick constraint options. So now I've got two objects constrained. I can still move them up and down along this axis because I haven't constrained any faces to it, and of course I can rotate the whole thing about that central axis as well. Now I want to bring up something that we call top-down design. This is a great time saver. It's very efficient to use existing designs to help the creation of new designs. So I'm going to add a new part to this assembly, and I'm going to select sheet metal part. So it keeps my file active in the background, but I'm actually generating a new part right now. So you can see within my assembly, I've got my original pulley, I've got my my hub here that I brought in as a generic part, and then I've got a third part that is actively being modified right now. So I can still use faces of this original assembly here to help me generate where my new body is going to be. So I'm going to create a sketch on that face. And since none of the reference geometry from that original sketch is actually going to carry over here, I'm just going to quickly create some reference geometry out of these two items here. And I'll delete those later. I just need those to help me generate this body real fast. So jump into my sketch mode. Delete the reference geometries. And I just want this to be symmetric about that axis. Oops, I want to keep those real fast. Use my mirror tool to mirror these three entities about that. And now I can go back in here and delete the items that I don't need. So again, I can use my just simple left click within the sketch window to go into my sheet metal features that I'm going to use. The tab is the main sheet metal body, so I'm going to start with that. And you can see it's creating a basic extrusion essentially from that sketch. I can do it in either direction here. I'll go ahead and leave it where it's at and hit OK. And it's created a new tab. Now, if I don't like the thickness of that sheet metal, I can change all of my parameters up here. So right now it's about 40 thousandths thick. If I wanted to change that to 0.8 and hit apply, you can watch it update here and made that a little bit thicker. I'm going to come over and use my flange tool now. And I'm going to select two edges that I want to create flanges off of. So pretty intuitive. It knows that my bend angle is going to be 90 degrees, but of course I can change that. And it gives me that dynamic preview. I can also change the offset a little bit. So if I wanted this to be 1/4 of an inch away from each of the walls here, it made those tabs a little bit shorter. And I can change the length as well. So let's try 1.5 to see if that covers everything. I'll go ahead and hit apply here, and it's created new tabs. And that's not quite what we want, because this sheet metal part is actually a belt guard, just in case the belt snaps. It doesn't take out anything else. So I want to go back in, and I can edit my original flange. So like I said, this is a parametric history-based modeler. Come back in here and change this to 2 inches. And hit OK. And it's now covering that full belt. Just add a couple extra detail items here. Put a couple fillets on these corners. And away we go. Now when I right-click my original assembly and edit that, it lets me go back to assembly mode. So from here, what we're going to do is add a couple of other items to this assembly. I'm just going to skip ahead a little bit, and we're going to go into motion analysis and FEA. So while I'm switching screens here, we'll go ahead and ask another poll question. Get that up on the screen here, give you about 20 seconds to answer that, and we'll get back to it. Okay, thanks again for answering all of that. So now that I have my assembly here, I brought that into Simulate for Geomagic Design. Now this is an add-on that does motion analysis as well as finite element analysis. You heard me say earlier that motion analysis comes packaged with Geomagic Design, and that's true. And that's kind of unique to Geomagic Design. That's definitely adds a lot of value to the software because everybody else charges you for that. With this, it's built in. Now, what you don't get with the basic motion analysis, though, is finite element analysis, which you see here. So this is Simulate. This is an add-on. It's an additional software piece that works with us. And what I've done is exported all of my constraints and assembly constraints and everything like that from the model, from the assembly model into Simulate here. So I don't have to recreate everything. Then what I did was I just added a couple of forces and then a motor to this motor here, and we can watch that motor run in real time. There we go. So what I just did was I created a pulley between the two items. Start over here. You can see this pulley. So you can get the gear ratios between everything, so on and so forth. I've also got static FEA going on right now on the sheet metal bracket as if it were what the hub and everything were attached to. But one of the advantages of Simulate for Geomagic Design is we can actually do dynamic FEA analysis, so you can watch vibration and everything as it's happening in real time, which is very, very cool, very, very powerful, and not very many other people do that, and certainly not at this cost. So I'm going to switch back here and We can use this to do 3D collision analysis and many, many other things. It's a very, very powerful and a pretty intuitive software to get to use. And once we have that, once we kind of validated that our assembly is correct, we'll go back into documenting these parts for manufacture. So I'm going to switch back over here and bring up my Geomagic design screen. So this is my final assembly. And if I go into my home window again, I can create engineering drawings from some of my parts. So it's going to ask me what my template is that I'm going to use first of all, and the default ANSI template is, excuse me, okay for me. I can change the name to bracket. And then it's going to ask me just to fill in some of the generic items here. So, is it the 5th today? Drawing number 2. And when I bring that up, it opens up the part document. And I actually don't want to document my pulley. I want to find that sheet metal part of mine, but I don't think I've actually saved that. So let me just jump back in here and save this real quick. Damn. Now I can find where I put that on my desktop. Grab my new sheet metal part. There it is. And set the views that I want to come in. So I've got a front, top, and right, standard drawing style, and hit OK. And it's just going to show me where I'm going to place that on my drawing. So I can put that right here, and it adds those. But since this is a sheet metal part, what I want to do is I want to add another view where it's just the unfolded version of that part. So if I go back into sheets and views, I can add a standard view. And when I click more options, I have the project as flat pattern view, and it's giving me a preview of what that's going to look like. So I can go ahead and accept that and add that view right here. And from here, I can just go ahead and add datums or dimensions, anything like that. So I'm going to add a dimension to this face. If you just scroll in, you can see that that's 1.96. It's pretty easy because it's all linked. You can just click on faces and edges, and it applies the datums and everything to that. So now I want to save this. I'm just going to grab And what's really cool about Geomagic Design is all of these items are linked. The assemblies, the parts themselves, the sheet metal parts, the solid models, and the drawings are all dynamically linked to one another. So if I go back into my assembly here, and I want to edit my sheet metal bracket, let's say I want to change this dimension. So I'm going to edit my flange again. And I'm going to change that dimension to, how about 3? You can see it's updating here. I'll go ahead and resave this. And it's going to modify the new assembly and the sheet metal part. And when I track back into my drawing, I need to go to reproject views, and that's just going to update everything that I've got. The same thing would happen if I just opened this part again, if I close it down, and you can see everything's updated itself. So when I scroll back in here, you can see that that dimension has been modified. So you're never going to have an out-of-date drawing. Everything's going to be linked all the time, which definitely helps with efficiency. You're never going to be looking at outdated stuff. So the last thing that I wanted to do was render this whole thing in KeyShot. But the problem is we tested it with the webinar the other day, and it really kind of makes everything a little glitchy. KeyShot requires a lot of it's very processor intensive, it's very resource intensive, and so is GoToWebinar. So unfortunately, I'm not going to be able to do that live for you today, but you noticed probably in the in this that we have rendered images. So of that watch there, this is photorealistic rendering. KeyShot is included with both Geomagic Design and Design Elements, and it's very, very powerful. So once you've kind of validated and documented everything, we can switch back into KeyShot, where Geomagic Design will actually write a what is it, .bmp file, and it will go directly into KeyShot where you can edit it there.